Hello, everybody. Welcome back again. My name is Marvin Smith, and I am doing a reaction video on the NVIDIA Keynote. So this keynote's been on my list for a while to watch and review. I've seen a few snippets of it, but for this keynote here, this is the one he did in Taiwan, which is pretty much has like I think 100, like maybe 1.2 million views on YouTube. So this is the more, I want to say, consumer friendly keynote. So I'm going to do that. But he did another keynote, which is called GPU Technology Conference, which is more engineered gear technology conference. So I'm just doing a reaction video on this. I've seen snippets, but I'm just going to give you my thoughts and views. I'm gonna do a part 2 because this keynote is actually an hour and 49 minutes, an hour and 50, give or take. So I'm just gonna do a part 1 and part 2 and just give you my thoughts on it. All right.
All right, let's get started.
Good take, good take.
Oh, jeez.
And cut. Okay, you guys ready?
Yeah.
Everybody thinks we make GPUs. NVIDIA is so much more than that. This whole keynote's going to be about that.
Okay, so we'll start at the top.
Examples of the use cases and then seeing it in action. That's kind of the flow.
It's such a compelling story. I'm super nervous about this.
Just gotta get in the rhythm.
We're 2 weeks away from it. You guys can go really, really make it great.
We should take a swing at it.
Yeah, that's the plan. I think we need to get daily status on that animation.
Can you mute? Because I hear myself.
Sorry.
What's the drop date for all the videos?
It needs to be done on the 28th.
Did you get all that?
Safe travels, everybody.
Super excited to see everyone.
See you guys soon. Okay. Bye.
We're basically moving as fast as the world can absorb technology, so we've got to leapfrog ourselves. Now the scientists have to figure out a way to make it pop. You know what I'm saying? You know what I'm saying? You want to, yeah, that kind of thing. Thank you. I'm super late. Let's go.
So a little back note. So Jensen Huang is pretty much a Taiwanese native. Grew up in Taiwan, came to the United States, pretty much an immigrant, and built the company from the ground up. Definitely one of the tech billionaires that I admire. Not so much the fact that, you know, he's a young tech billionaire, but the fact that, you know, he went to school, pretty much hustled just to build a company, and, you know, built it from the ground up. And those are one of the things that I admire. It basically lets you know that, you know, you don't have to kind of cut corners and things like that. You just got to put in the work. So let's get into it.
欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
Please welcome to the stage NVIDIA founder and CEO, Jensen Huang.
So, yeah, just seeing a little bit of lag, so I'm just going to lower the resolution.
大家好。
I am very happy to be back. Thank you, NTU, for letting us use your stadium. The last time I was here, I received a degree from NTU. And I gave the run, don't walk speech. And today we have a lot to cover. So I cannot walk, I must run. We have a lot to cover. I have many things to tell you. I'm very happy to be here in Taiwan. Taiwan is the home of our treasured partners. This is, in fact, where everything NVIDIA does begins. Our partners and ourselves take it to the world. Taiwan and our partnership has created the world's AI infrastructure. Today, I want to talk to you about several things. One, what is happening and the meaning of the work that we do together? What is generative AI? What is its impact on our industry and on every industry?
So just talking a little bit about generative AI. AI has been around, for years. It's nothing new, but generative AI is what's the game changer. You train the AI model, and then you you have ChatGPT, and then there's a few others out there, but the most notable one is ChatGPT. You type in a question and it generates the answer, or you're looking for a design on something and it would generate the answer. That's what's the game changer right now, is the generative AI. And it basically thinks faster, never sleeps, and it's one of those game changing things right now. That's why I say it's a great time to be alive right now. We're in the era of AI. We're in the era of the fourth industrial revolution. And this is definitely a pivotal point right now.
A blueprint for how we will go forward and engage this incredible opportunity. And what's coming next? Generative AI and its impact, our blueprint, and what comes next. These are really, really exciting times. A restart of our computer industry, an industry that you have forged, an industry that you have created, and now you're prepared for the next major journey. But before we start, NVIDIA lives at the intersection of computer graphics, simulations, and artificial intelligence. This is our soul. Everything that I show you today is simulation. It's math, it's science, it's computer science, it's amazing computer architecture. None of it's animated, and it's all homemade. This is NVIDIA's soul, and we put it all into this virtual world we call Omniverse. Please enjoy.
So as a gamer myself, just look at the realism in those features. Let's go back just a little bit.
World we call Omniverse. Please enjoy.
So yeah, look at that realism. Look at the water that's coming down on this person's face, or this This is not a real person, but this is just all simulation. But look at the realism. Think about what this is going to do for gaming. More real looking characters, NPCs that look more like resemble human beings. So yeah, this is amazing right here. The shadowing on the face.
阮兜做袂歹看吼。I want to speak to you in Chinese, but I have so much to tell you, I have to think too hard to speak Chinese. So I have to speak to you in English. At the foundation of everything that you saw was two fundamental technologies.
Yeah, I mean, I gotta always say, like, whenever I see Jensen Huang, he has black on, and whoever his stylist is, definitely like that person's got some taste, because I'm loving that leather jacket right there. I would have gone with a black and gold finish on the zippers maybe, but definitely whoever his stylist is definitely has some taste, man. I gotta say shout out to the stylist.
Technologies, accelerated computing, and artificial intelligence running inside the Omniverse. Those two technologies, those two fundamental forces of computing are going to reshape the computer industry. The computer industry is now some 60 years old. In a lot of ways, everything that we do today was invented the year after my birth, in 1964. The IBM System 360 introduced central processing units, general purpose computing, the separation of hardware and software through an operating system, multitasking, I/O subsystems, DMA, all kinds of technologies that we use today, architectural compatibility, backwards compatibility, family compatibility, all of the things that we know today about computing largely described in 1964. Of course, the PC revolution democratized computing and put it in the hands and the houses of everybody. And then in 2007, the iPhone introduced mobile computing and put the computer in our pocket. Ever since, everything is connected.
Yeah, so pretty much I did a reaction video to Governor Holcomb basically saying that kids don't understand computers, but again, we walk around with a supercomputer in our pockets. It's called a mobile device, a mobile phone. That that mobile phone has more computing power than, this IBM. I don't even remember what it's called right now. It is a specific name for it, but this IBM S360 that was created in 1964, the iPhone has more computing power than these clusters of machines. Actually, there's some companies out here that are still running. They're called mainframes. So there are companies out here today that are still running their solution on mainframes. One big retailer that I did a consultant for basically is still running, I want to say 30% on their infrastructure, 30% of their infrastructure on an IBM mainframe. So yeah, they're still out there. But back to what I was saying is we walk around with more computing power in our pockets now than ever before. So when I heard that comment from Governor Holcomb, I basically said these politicians are so disconnected from society. It's not even it's so ridiculous. So, but let's continue.
Connected and running all the time through the mobile cloud. This last 60 years, we saw just several, not that many actually, 2 or 3 major technology shifts, 2 or 3 tectonic shifts in computing, where everything changed. And we're about to see that happen again. There are 2 fundamental things that are happening. The first is that the processor, the engine by which the computer industry runs on, the central processing unit, the performance scaling has slowed tremendously. And yet, the amount of computation we have to do is still doubling very quickly, exponentially. If processing requirement, if the data that we need to process continues to scale exponentially, but performance does not, we will experience computation inflation. And in fact, we're seeing that right now as we speak. The amount of data center power that's used all over the world is growing quite substantially. The cost of computing is growing. We are seeing computation inflation. This, of course, cannot continue. The data is going to continue to increase exponentially, and CPU performance scaling will never return. There is a better way. For almost 2 decades now, we've been working on accelerated computing. CUDA augments a CPU, offloads and accelerates the work that a specialized processor can do much, much better. In fact, the performance is so extraordinary that it is very clear now, as CPU scaling has slowed and eventually substantially stopped, we should accelerate everything. I predict.
So just pausing it for a little bit here. So he has a point. Basically, I think CPU overall computing performance hasn't scaled. I think since 1992, or no, it hasn't scaled since maybe 2000. It's been on a slow, steady decline. But we have more data. We have more data that's surrounding us now than ever before. So you need something to kind of off to something that's dedicated to kind of process all that data, and something that's specifically built to process the massive amount of data that's out there. So this is why GPU is important, and especially with AI, you could run AI on a CPU, but you won't get the maximum performance on a GPU. You won't get the same performance from a GPU on a CPU. So this is why GPUs are so important right now.
That every application that is processing intensive will be accelerated, and surely every data center will be accelerated in the near future. Now, accelerated computing is very sensible. It's very common sense. If you take a look at an application, and here the 100T means 100 units of time. It could be 100 seconds, it could be 100 hours, and in many cases, as you know, we're now working on artificial intelligence applications that run for 100 days. The 1T is code that requires sequential processing, where single-threaded CPUs are really quite essential. Operating systems, control logic, really essential to have one instruction executed after another instruction. However, there are many algorithms, computer graphics is one, that you can operate completely in parallel. Computer graphics, image processing, physics simulations, combinatorial optimizations, graph processing, database processing, and of course, the very famous linear algebra of deep learning. There are many types of algorithms that are very conducive to acceleration through parallel processing. So we invented an architecture to do that by adding the GPU to the CPU. The specialized processor can take something that takes a great deal of time and accelerate it down to something that is incredibly fast. And because the two processors can work side by side, they're both autonomous and they're both separate, independent that is, we could accelerate what used to take 100 units of time down to 1 unit of time. Inflation for so long in general purpose computing, now that we finally determined to accelerate, there's an enormous amount of captured loss that we can now regain. A great deal of captured, retained waste that we can now relieve out of the system, and that will translate into savings. Savings in money, savings in energy. And that's the reason why you've heard me say, the more you buy, the more you save. And now I've shown you the mathematics. It is not accurate, but it is correct. Okay, that's called CEO math. CEO math is not accurate, but it is correct. The more you buy, the more you save. Well, accelerated computing does deliver extraordinary results, but it is not easy. Why is it that it saves so much money, but people haven't done it for so long? The reason for that is because it's incredibly hard. There is no such thing as a software that you can just run through a C compiler and all of a sudden that application runs 100 times faster. That is not even logical. If it was possible to do that, they would have just changed the CPU to do that. You, in fact, have to rewrite the software. That's the hard part. The software has to be completely rewritten so that you could refactor, re-express the algorithms that was written on a CPU so that it could be accelerated, offloaded, accelerated, and run in parallel. That computer science exercise is insanely hard. Well, we've made it easy for the world over the last 20 years. Of course, the very famous cuDNN, the deep learning library that processes neural networks. We have a library for AI physics.
So these are libraries within the CUDA architecture. So I believe he's going to go through some of these libraries and kind of explain what they do. But let's continue.
That you could use for fluid dynamics and many other applications where the neural network has to obey the laws of physics. We have a great new library called Ariel that is a CUDA accelerated 5G radio so that we can software define and accelerate the telecommunications networks the way that we've software-defined the world's networking internet. And so the ability for us to accelerate that allows us to turn all of telecom into essentially the same type of platform, a computing platform, just like we have in the cloud. cuLitho is a computational lithography platform that allows us to process the most computationally intensive parts of chip manufacturing, making the mask. TSMC is in the process of going to production with cuLitho, saving enormous amounts of energy and enormous amounts of money. But the goal for TSMC is to accelerate their stack so that they're prepared for even further advances in algorithm and more computation for deeper and deeper, narrow and narrow transistors. Parabricks is our gene sequencing library. It is the highest throughput library in the world for gene sequencing. cuOpt is an incredible library for combinatorial optimization, route planning optimization, the traveling salesman problem, incredibly complicated. Scientists have largely concluded that you needed a quantum computer to do that. We created an algorithm that runs on accelerated computing that runs lightning fast. 23 world records. We hold every single major world record today. cuQuantum is an emulation system for a quantum computer. If you want to design a quantum computer, you need a simulator to do so. If you want to design quantum algorithms, you need a quantum emulator to do so. How would you do that? How would you design these quantum computers, create these quantum algorithms?
So I've heard people talk about quantum computers, blah blah blah, useless conversation. But again, this goes back to what I was saying. Instead of building a quantum computer, just simulate the code in the cloud, or run it on some, design it from a virtual standpoint, then see how it runs before you even build it. But quantum computers, we're not at that stage yet in society. It's coming, but again, nobody really knows what to do with a quantum computer if they have it. So
if the quantum computer doesn't exist, well, you use the fastest computer in the world that exists today, and we call it, of course, NVIDIA CUDA. And on that, we have an emulator that simulates quantum computers. It is used by several 100,000 researchers around the world. It is integrated into all the leading frameworks for quantum computing, and is used in scientific supercomputing centers all over the world. cuDF is an unbelievable library for data processing. Data processing consumes the vast majority of cloud spend today. All of it should be accelerated. cuDF accelerates the major libraries used in the world. Spark, many of you probably use Spark in your companies. Pandas, a new one called Polar, and of course, NetworkX, which is a graph processing database library. And so these are just some examples. There are so many more. Each one of them had to be created so that we can enable the ecosystem to take advantage of accelerated computing. If we hadn't created cuDNN, CUDA alone wouldn't have been possible for all of the deep learning scientists around the world to use, because CUDA and the algorithms that are used in TensorFlow and PyTorch, the deep learning algorithms, the separation is too far apart. It's almost like trying to do computer graphics without OpenGL. It's almost like doing data processing without SQL. These domain-specific libraries are really the treasure of our company. We have 350 of them. These libraries is what it takes and what has made it possible for us to have such open so many markets. I'll show you some other examples today. Well, just last week, Google announced that they put cuDF in the cloud and accelerate Pandas. Pandas is the most popular data science library in the world. Many of you in here probably already use Pandas. It's used by 10 million data scientists in the world, downloaded 170 million times each month. It is the Excel, it is the spreadsheet of data scientists. Well, with just one click, you can now use Pandas in Colab, which is Google's cloud data centers platform, accelerated by cuDF. The speed up is really incredible. Let's take a look. That was a great demo, right? Didn't take long. When you accelerate data processing that fast, demos don't take long. Okay, well, CUDA has now achieved what people call a tipping point, but it's even better than that. CUDA has now achieved a virtuous cycle. This rarely happens. If you look at history and all the computing architectures, computing platforms, in the case of microprocessors, CPUs, it has been here for 60 years. It has not been changed for 60 years. At this level, this way of doing computing, accelerated computing, has been around, creating a new platform is extremely hard because it's a chicken and egg problem. If there are no developers that use your platform, then of course there will be no users. But if there are no users, there are no install base. If there are no install base, developers aren't interested in it. Developers want to write software for a large install base, but a large install base requires a lot of applications so that users would create that install base. This chicken or the egg problem has rarely been broken, and it's taken us now 20 years, one domain library after another, one acceleration library another, and now we have 5 million developers around the world. We serve every single industry, from healthcare, financial services, of course, the computer industry, automotive industry, just about every major industry in the world, just about every field of science. Because there are so many customers for our architecture, OEMs and cloud service providers are interested in building our systems. System makers, amazing system makers like the ones here in Taiwan are interested in building our systems, which then takes and offers more systems to the market, which of course creates greater opportunity for us, which allows us to increase our scale, R&D scale, which speeds up the application even more. Well, every single time we speed up the application, the cost of computing goes down. This is that slide I was showing you earlier. 100x speed up translates to 97, 96%, 98% savings. And so when we go from 100x speed up to 200x speed up to 1000x speed up, the savings, the marginal cost of computing continues to fall. Well, of course, we believe that by reducing the cost of computing incredibly, the market, developers, scientists, inventors will continue to discover new algorithms that consume more and more and more computing, so that one day something happens, that a phase shift happens, that the marginal cost of computing is so low that a new way of using computers emerge. In fact, that's what we're seeing now. Over the years, we have driven down the marginal cost of computing in the last 10 years in one particular algorithm by 1 million times. Well, as a result, it is now very logical and very common sense to train large language models with all of the data on the internet. Nobody thinks twice. This idea that you could create a computer that could process so much data to write its own software, the emergence of artificial intelligence was made possible because of this complete belief that if we made computing cheaper and cheaper and cheaper, somebody's going to find a great use. Well, today, CUDA has achieved the virtuous cycle.
So just touching on what he was saying, one of the downsides of AI is that it has to run on GPU servers, and GPU servers are extremely expensive. But what Jensen is saying, basically, if you bring down that cost, GPU computing acceleration in itself becomes more affordable for companies to create whatever they need. You could train large language models, which is definitely expensive, but to bring down that cost, that GPU cost, and kind of bring down the cost and increase the accelerating computing process. You basically make it more affordable to anybody and more accessible to anyone.
Install base is growing, computing cost is coming down, which causes more developers to come up with more ideas, which drives more demand. And now we're in the beginning of something very, very important. But before I show you that, I want to show you what is not possible if not for the fact that we created CUDA, that we created the modern version of the modern big bang of AI, generative AI. What I'm about to show you would not be possible. This is Earth 2. The idea that we would create a digital twin of the Earth, that we would go and simulate the Earth so that we could predict the future of our planet to better avert disasters or better understand the impact of climate change so that we can adapt better, so that we could change our habits now. This digital twin of Earth is probably one of the most ambitious projects that the world's ever undertaken, and we're taking large steps every single year, and I'll show you results every single year, but this year we made some great breakthroughs. Let's take a look.
On Monday, the storm will veer north again and approach Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on Taiwan.
想象我们处于一个能够预测未来的世界，数位孪生是一种反映真实世界的虚拟模型，让我们能够从今天的行为来预测对未来世界的影响。容许我向您介绍 NVIDIA Earth 2， 一个利用 AI、物理模拟和电脑图形技术来预测全球气候的数位孪生。Core Diff 是 NVIDIA 的生成式 AI 模型，它在 WRF 数值模拟的基础上训练而成，能够以12倍更高的解析度生成天气模式，从25公里提高到2公里，这代表了区域天气预测的一个巨大飞跃。令人惊讶的是 ，Core Diff AI 比传统的物理模拟方法快1000倍，且能源效率高3000倍。下冲这样的现象，当强风汇聚到街道层，会有可能造成损坏并影响行人。NVIDIA Earth 2是数位孪生的一个绝佳范例，它融合了人工智慧、物理模拟和观测数据，可以帮助国家和公司预见未来，并应对极端天气的影响。
Someday, in the near future, we will have continuous weather prediction at every square kilometer on the planet. You will always know what the climate's going to be. You will all.
So, I'm going to talk about this in like a second, but I attended a Microsoft, I believe it was Microsoft Insight. Again, Microsoft is all 10 toes down for AI. So one of the presenters basically said they now have a large language model that we could predict and follow weather patterns and predict the next hurricane, the next typhoon, things like that. So I believe what NVIDIA now has is what's called Earth 2. They could now use this to kind of predict the same thing, but they just now covered the whole globe. And I think this is going to be instrumental for definitely the construction industry if they market it right, in my opinion, because you could actually, before you build that 100-story building, you could see what the weather pattern is going to be. You could actually see what harsh rain, whatever tornado like effects could be on this building before you even build it. You could build that building virtually on Earth 2, and then kind of just predict all that stress on the building. Not a construction person, but I'm assuming this is what you could do with things like this.
Always know. And this will run continuously because we've trained the AI, and the AI requires so little energy. And so this is just an incredible achievement. I hope you enjoyed it. And very importantly, 我的国语讲的标准吗？ The truth is, that was a Jensen AI. That was not me. I wrote it, but an AI, Jensen AI, had to say it. 我的国语不够好。 That is a miracle. That is a miracle indeed. However, in 2012, something very important happened. Because of our dedication to advancing CUDA, because of our dedication to continuously improve the performance of drive the cost down, AI researchers discovered CUDA in 2012. That was NVIDIA's first contact with AI. This was a very important day. We had the good wisdom to work with the scientists to make it possible for deep learning to happen. And AlexNet achieved, of course, a tremendous computer vision breakthrough. But the great wisdom was to take a step back and understanding what was the background, what is the foundation of deep learning? What is its long-term impact? What is its potential? And we realized that this technology has great potential to scale. An algorithm that was invented and discovered decades ago.
So I'm just going to skip it.
All of a sudden, because of more data, larger networks, and very importantly, a lot more that we continue to scale. All of it came together on a brand new computer nobody understood. Nobody asked for it, nobody understood it, and in fact, I was certain nobody wanted to buy it. And so we announced it at GTC, and OpenAI, a small company in San Francisco, saw it, and they asked me to deliver one to them. I delivered the first DGX, the world's first AI supercomputer, to OpenAI.
So, like I was saying before, AI requires GPU. AI requires GPU, it needs GPU to run on. So I've heard about this some time back, that OpenAI runs on NVIDIA GPU servers. So this is actually a GPU supercomputer, that the very first one. I might find that GTC where he talks about it, and probably do a review later on if I can find it. But this is what OpenAI was first running on. It's not running on it now, but it's basically like, this is what the proof of concept was. It needed something like this to run on in order for it to be, the generative AI that it is today. So this is why I'm basically a strong advocate for, you know, technology being advanced and things like that, because if the hardware software solution is there, then you could definitely build on top of it and build something good.
In 2016. Well, after that, we continued to scale. From one AI supercomputer, one AI appliance, we scaled it up to large supercomputers, even larger. By 2017, the world discovered transformers so that we could train enormous amounts of data and recognize and learn patterns that are sequential over large spans of time. It is now possible for us to train these large language models to understand and achieve a breakthrough in natural language understanding. And we kept going after that. We built even larger ones. And then in November 2022, trained on thousands, tens of thousands of NVIDIA GPUs in a very large AI supercomputer, OpenAI announced ChatGPT. 1 million users after 5 days. 1 million after 5 days, 100.
That's definitely impressive. Like, most apps don't even achieve that amount of users in a short time, and even if they do, they end up crashing. Something crashes on the back end. But the fact that ChatGPT was able to gain so many users in a short time and still be able to kind of run, that's definitely impressive.
1 million after 2 months, the fastest growing application in history. And the reason for that is very simple. It is just so easy to use, and it was so magical to use. To be able to interact with a computer like it's human. Instead of being clear about what you want, it's like the computer understands your meaning. It understands your intention. Oh, I think here it asked the closest night market. As you know, the night market is very important to me. So when I was young, I think I was 4.5 years old. I used to love going to the night market because I just love watching people. And so we went, my parents used to take us to the night market. Yuan Huan, 讲对吗? Yuan Huan, 去吃蚵仔煎. And I love going. And one day, my face, you guys might see that I have a large scar on my face. My face was cut because somebody was washing their knife, and I was a little kid. But my memories of the night market is so deep because of that. And I used to love, I still love going to the night market. And I just need to tell you guys this: the Tonghua night market is really good because there's a lady. She's been working there for 43 years. She's the fruit lady, and it's in the middle of the street, the middle between the two. Go find her, okay? She. 做赞的，在喝价。She's really terrific. I think it would be funny after this, all of you go to see her. Every year she's
so I'm just
going to
skip some parts and just fast forward a bit.
Generated electrons. NVIDIA filtering, it was generating. And so we can use this method to generate tokens for almost anything. Nikola Tesla invented an AC generator. We invented an AI generator. The AC generator generated.
So this part is what I've heard about, where he talks about creating an AI factory, because how can I? Every industry needs some sort of specific AI model so it could understand how to do better things and so forth. So what I believe he's done with this is that he basically said, hey, we created an AI factory for different industries or but let me continue.
Electrons. NVIDIA's AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution. We have now a new factory producing a new commodity for every industry that is of extraordinary value. And the methodology for doing this is quite scalable. And the methodology of doing this is quite repeatable. Notice how quickly so many different AI models, generative AI models, are being invented, literally daily. Every single industry is now piling on. For the very first time, the IT industry, which is $3 trillion, $3 trillion IT industry, is about to create something.
Yeah, this is what I always say, like the IT industry is lucrative. It's just again a $3 trillion industry. And I guess, and I don't want to say I guess, but again, there's not a lot of us in the right places to reap the benefits of a $3 trillion industry. So again, it's just it blows my mind. I've been telling people this for years, like the IT industry is so lucrative, but again, there's not enough of us to reap the benefits of a $3 trillion a year industry
that can directly serve $100 trillion of industry. No longer just an instrument for information storage or data processing, but a factory for generating intelligence for every industry. This is going to be a manufacturing industry, not a manufacturing industry of computers, but using the computers in manufacturing. This has never happened before. Quite an extraordinary thing. What started with accelerated computing, led to AI, led to generative AI, and now an industrial revolution. Now the impact to our industry that Microsoft created for packaging software revolutionized the PC industry. Without packaged software, what would we use the PC to do? It drove this industry. And now we have a new factory, a new computer. And what we will run on top of this is a new type of software. And we call it NIMS, NVIDIA Inference Microservices. Now, what happens is the NIM runs inside this factory. And this NIM...
So I'm going to stop it right here, because I definitely want to get into talking about NIMS and what their capabilities are. So, and we're just basically just scratching the surface right now. So we're about 44 minutes in, 45 minutes into the keynote, but I definitely want to talk about.
Stay up, counting all the way up, count blessings, and you know we pray up, way up, on track.